So, good morning. My name is Starke. Today we present to you quantum observables reality Erasure with space-like-separated operations. This work is still a draft. It's reading collaborations of UFSM by myself and my advisor, by the UFPR in the name of Erasure, and the experimental realization by the UFRJ with Jailson Araújo, Antônio Coelho, and Gabriel Aguilar, now in this EPR. So classical physics is based in two concepts, realism and local causality. Reality is related to the your known properties of your system, which is all available in each instant of time, and local causality is related to the modifications of your reality properties by the surrounding of your system. So EPR used this notion, Isaac and Oscar Rose in 1935, used these classical notions of reality and local causality to argue that the quantum mechanics is incomplete. In contrast, we have the Bohr's view, where we need to measure our system to find some reality properties about the quantum system. In this work, we are using the quantum reality as proposed by the Neumann and Renato Langelo, and we rise and answer this question. Can local operations at any site influence the elements of reality of observables in one site if they are space-like separated? So here I brought a summary of the EPR debate, the EPR paradox. For example, we have a neutron meson P that can decay, which are low probability in a pair of electron and positron. So you can send your electron to Alice laboratory and the positron to Bob's laboratory. And if you guarantee that the operations is outside of the light cone of each other, to guarantee the conservations of your total angular momentum, to describe the spin of these two quantum systems need to be described by an entangled state. For example, cat 0 representing the spin up and cat 1 for spin down. So if you measure, Alice measure her quantum system in the of the observable Z, for example, getting 0, in the EPR notions of reality, they say that we have a definite element of reality in the Bob's laboratory. And if you rewrite your quantum state in for a incompatible observable, the eigenstates of this observable, you also get an entangled state. And if I is measured in this for this observable, we also have definitive elements of reality in Bob's laboratory by the EPR notion. So, by the quantum mechanics, these observables are incompatible. So, this lead the EPR to lead the incompleteness of quantum mechanics. We have problems with these notions of reality for quantum systems. And also we have problems of quantifications for partially incompatible observables, for example. So using the notions of elements of reality constructed by Neumann and Angelo can be summarized in these steps. You prepare your quantum system, you perform a quantum state tomography to verify your preparation, get your density matrix home. And if after your preparation you construct a non-selective measurement for a given observable, and after this process you provide a quantum state tomography again to get in this PA of code, it's a new state. If you have this criteria established as your quantum system is equal to the map of this measuring process acting in your quantum system, this is a criterion for realism. In other words, the measuring process only reveals an element of reality pre-existing. They define a quantifier named as irreality, where we provide the different of these two quantum states, and we find that if this criteria is established, this quantity is equal to 0. In other words, we don't have manifestations of properties of quantum mechanics like entanglement and superposition. So, for example, if you know in a double slit experiment the path that your quantum system takes, you have one element of reality for this path observable. You can also rewrite, and if you don't know the path taken by your quantum system, you have superposition, so you have this quantity equal 1 in this case. So you can rewrite this quantity as the sum of quantum coherence and quantum discord. Quantum coherence quantified as superposition, and quantum discord quantified as a particular case the entanglement. So we are applying these notions of elements of reality as proposed by these two researchers. We use this experimental setup, which is executed by the UFA job. So we have a source that constructs the entangled pair after passing by this device, BDO. It's a Bohr-Borato, price of a Bohr-Borato. One of these pairs we send for Alice, and the other one for Bob. In Alice's lab, she can make two choices, include or not this quarterly plate. And then we perform a post selection and a projective measurement with post selection. And the photon of Bob is sent in this kind of experiment. It's a Sagnac interferometer. We can also construct different entangled states. So we can rotate this half-wave plate. So we can vary for a separable state to a maximum entangled state. So related, C and S are related to this theta. So we are interested in looking for the elements of reality for the path inside of the interferometer for Bob by these two situations in the Alice laboratory. And we also include these two new degrees of freedom. This device is a beam displacer, which change the spatial positions of the photon. In one arm, we perform this horizontally. In the other arm, we do this vertically. So we also are interested in the elements of reality for these two degrees of freedom. Here we have the optical elements that execute this experiment. So this is the experimental results. In this case, we have a simplification of our experiment. So we have the entangled source that sends two entangled pairs to Alice and Bob. And when we look for the configuration CZ in the Alice side, when we look for the elements of reality of Bob, we have very specific elements of reality for the path and also for these 2 degrees of freedom. But when Alice changed her configurations, these elements of reality becomes fuzzy. In other words, we have the properties of quantum manifestations of properties of quantum mechanics. Analytically, we find that the CZ configurations, the irreality is 0 for every cases of the initial entangled state, partial entangled state, and the maximum entangled state. In other words, we have elements of reality for the path and also for these 2 degrees of freedom. When she changed her configurations, we find that the irreality in this case is given by this expression. And we also find that the elements of reality for these 2 degrees of freedom is given by the same expression. But the nature of the irreality for this case are different. In one case, we have the superposition. In the other case, it's because of the entanglement of these 2 additional degrees of freedom. So, because of this result, we propose a way to solve some problems in Bohr's complementarity principle. For example, that relying problems that retro-inference. So the quantifications of the entanglement of these 2 degrees of freedom solve parts of this problem. And the experimental results, here we have the reality for the path, for these degrees, 2 degrees of freedom. In the bottom of these 2 graphs, the dashed black line represents the case for configuration CZ. So we have elements of reality for different configurations of entanglement initial intermediate state. But when she changed her configurations, the red line represents that the reality is increasing. In other words, we are raising these elements of reality in proportion of the initial intended state. That's it. So this experiment, we have demonstrated that the quantum operations performed in Alice labs can correlate with the erasure of the elements of reality in Bob's system, even under this space-like separation. I forgot to say this, but we need this 45 meters to guarantee this space-like separation. This is the distance that we find in the UFR. Of course, these results challenge the classical notions of reality, reinforcing the non-local features of quantum mechanics. Different of conventional experiments, which rely on ferrometric visibility and are susceptible in retro-inference, we solve this kind of problems proposing the quantifications of, for example, superposition by the entanglement of these 2 additional degrees of freedom. And these results advance the EPR by shifting this kind of reality discussion that I said before, using this new way to quantify the quantum reality, which is a informatical theoretical matter. Thank you.